Hello and good afternoon, CSI258 Section 847 students. For the second 8-week term and the final course in the Cisco Networking Academy curriculum, Connecting Networks. This is Networking 4, and this evening's PacketTracer tutorial is going to be on PacketTracer Activity 4.2.1.4, where we're going to be configuring frame relay. And we're actually going to be configuring frame relay using static frame relay maps. And if you remember from the reading in Chapter 4, remember that frame relay, even though it's sort of a technology that's withering on the vine due to other WAN access methods that are far less expensive and more flexible and far faster, frame relay is still a technology that you may run into out in the field. And so frame relay is really based off the dynamic inverse ARP, right? So it's kind of the opposite of what we looked at in the 157 and 158 courses, where we talked about a local area network where we would have ARP, and the address resolution protocol would take a layer 3 address, take an IP address like 192.168.1.10, and if the layer 2 address, right, at the layer 2 level, maybe on your layer 2 switch was unknown, what ARP would do is it would actually send out an ARP request, a broadcast, on the layer 2 domain, saying, hey, I've got the layer 3 address for 192.168.1.10. If this is you, can you please respond back to me and give me your MAC address? Because the switch needs to know how to be able, I need to know when I send this packet to the switch, where is the packet gonna, or the frame I should say, where is the frame gonna be forwarded to? Out which port is that frame gonna be forwarded? And so dynamic inverse ARP, which is what frame relay uses, is just the opposite. So for frame relay, right, instead of taking a layer 3 address and then doing a layer 2 resolution, frame relay is going to take a layer 2 address, and in this case it's going to be the DLCI, right, the DLCI, and it's going to go ahead and take that DLCI value, and it's going to go ahead and figure out what the IP address should be. And now that's how it works when it's working dynamically, but what we're going to do here is we're actually going to statically set the frame relay map. So let's go ahead and jump in here. So it says configure frame relay encapsulation on the serial 00 interface of R1. So let's jump on to R1 here. I've actually made the font. This is as large as it gets. So we're going to go ahead and go from user exec to privilege exec into global config, and then I'm going to go into interface configuration mode. And we're going to say encap, and I'm going to do the question mark here because in the previous chapter, chapter 3, we talked about HDLC and we talked about PPP. And so sort of the evolution of those two technologies was frame relay, because HDLC and PPP, those worked with leased lines, right, or dedicated circuits that you would get from your telco provider. And so back in the day, if I had, we'll say, and let's make that a lot smaller than it is there, and let me clear the screen. So if I had a router here, let's say it's router 1, and I wanted to connect it to router 2, and I was going to use a dedicated circuit lease line, I would need an interface here and an interface here. If I added a third router in, router 3, and I wanted to do a full mesh, I would need another interface here, an interface on router 3 here, and then another interface on router 1. And then it gets even worse when I add in a fourth router, right? Or this could be a fourth site. Let's say that this is Los Angeles, this is New York, and what is this going to be? This will be Chicago, and this will be Miami, right? And if I want a full mesh, I've got a circuit here, a circuit there, a circuit over here. So now we've got 1, 2, 3, 4, 5, 6 additional circuits. How we've got in total there? So 3 on each of these guys. So as you can see, this is not going to scale very well because I'm chewing up all of the interfaces on my router for each of these dedicated circuits. And so what frame relay said when it was created was, let's go ahead and clear that out. What frame relay did was it said, well, we're going to take a router, we'll say router 1, you're going to get a single circuit that connects into our frame relay service, or the frame relay cloud, we'll call it, right? And so then if you had, and this is LA, we'll say over here in New York, if you wanted to mesh with New York just needs a single circuit, right? Now if a third router were to come online, and we'll say this is router 2, if a third router here in Chicago comes online, he gets a single circuit, and all we need to do would be to create, and we're actually going to be doing something very similar over here. You could simply do sub interfaces, or you can do what we're going to be doing over here, which is just simply connecting these guys up based off the serial 00 interface. So again, a single circuit sort of allowing me to communicate with the service provider's frame relay cloud, and all I need is one single interface off my router to allow me to communicate with everybody out in that frame relay cloud, right? And so sort of the maturation of frame relay was right around 1997 with the introduction of MPLS, or the multi-protocol label switching, which kind of took frame relay to the next level. And once the traffic with frame relay, once your traffic enters the frame relay cloud, it's not really the IP address that it's being switched on, right? It's the delc value, okay? And so in the book, it actually showed you that drawing. It had the huge cloud, and then it had all the little boxes in there for the routers, and it showed you that the traffic would come in here and then go to this switch, then this switch, and then it would make its egress out to router 2. Right? And so the decision-making process in the cloud is being based on the delc value. So when this frame relay switch receives the packet, it's going to do a lookup in its table and say, oh, if you're going over here to delc 102, then you're going to go to this switch. And then this switch does a lookup and says the fastest way to get you there is this frame relay switch. And then this switch does a lookup and says, okay, that's my egress out to this customer. And so it's using the delc value, as opposed to with traditional layer 3 routing. What are we looking at? We're looking at the source IP and the destination IP as we're making our decisions along the way. And as the decision goes along the way, it's the destination IP that's being looked at, and each hop sort of takes in that, right? The interface buffers the bits. It looks at the frame to make sure that the source and destination MAC are correct, and then it peeks into that layer 3 packet and says, what's the destination IP address? At which point the router will do a lookup in the RIB, the routing information base, and then if it has to do a recursive lookup to see, okay, well, for 192.168.1.0/24, out which interface do I go? And that's where it may do a recursive lookup in what's called the FIB, or the forwarding information base. And then it'll make its decision to send the packet out. But that's traditional sort of layer 3 routing. With frame relay, it's actually being routed, right? Or they refer to it as switched, based off the delc value, right? Okay, so let me clear the screen here, and let's jump back in here. So now we're going to go ahead and we're going to make our decision as to what kind of layer 2 encapsulation are we going to use, and we're going to make it frame relay. So I'll say frame relay, and I'll hit enter, and then it's asking us, it says configure the frame relay encap on router 2 and router 3. So let's do that in turn. So again, I'm going to say enable to get to privilege exec, and then conf t for global config. I'm going to go into the interface configuration mode, and we're simply going to say encap frame relay. And in fact, you could type enf, I believe, and that would be enough, right? For encap frame relay, it's just enf. And if I were to do a do show run, then there it is, encap frame relay. Now, something we saw here at the end, right, of the encap frame relay is the difference between the specific encapsulation type as to what you're going to use, right? So there are two types that you can use. You can use Cisco, which is your default, or you can use the option here, which is IETF. Now, this would be used if you were trying to interface with a non-Cisco router. So a Juniper router, an HP router, an Arista router, you would want to use IETF. And if you think about it, it's very similar to when we looked at HDLC, right? So HDLC is Cisco proprietary, and it doesn't work as the encapsulation. If you were using a Juniper router or an HP router, you would need to use what? You would need to use PPP, right? Encap PPP, and then that's going to go ahead and make it sort of the open standard. And the same thing here, right? So Cisco basically has their own sort of secret sauce with respect to the encap type. And again, by default, it's Cisco. And so we're going to leave it at Cisco. So encap frame relay is all we need here. And let's go over to router 3 and let's knock it out on router 3. So we're in user exec. We'll go to privilege exec, global config, and then interface configuration mode. And we'll just say enf do show run. And we've got encap frame relay. And so everything looks good right now. So step 3 here, it's asking us to test the connectivity, which we are probably not going to get working here. So at least for right now, it's probably not going to work. So it wants me to ping from the PC to laptop, and it should fail. And we're going to say 192.168.30.10. Is that correct? And that's the laptop's IP. And so we're getting destination host unreachable. And so this is not going to work, and that request is going to time out. And we're getting a reply back from 192.168.10.1, which is our default gateway here on router 1. So if I were to say do show run, and I think it went right by it there. There we go. So that is our default gateway on our local LAN segment is router 1. And as you can see, it's basically just telling us the network's unreachable. Do I have a route to that? So if I were to say do show IP route, do we have a route to 192.168.30? We do not, and we don't have a default gateway. Therefore, the router is going to return to me destination unreachable because we do not have a routing table entry for that. So another quick thing we need to take a look at here is we are running a routing protocol. It's been pre-configured for us, and so this is not a troubleshooting exercise. So therefore, everything is configured properly here just by taking a quick look at it. We've got our passive interface, and we have our 2 network statements. So we're trying to run EIGRP. So what if I say do show IP EIGRP neighbors? Right? I don't have any neighbors right now. Even though we've set the encapsulation, right, it's a little different than the previous layer 2 encaps that we looked at, the HDLC and the PPP. Remember, with HDLC, everything kind of worked. You know, it was by default, HDLC is there, and so I throw some slap IPs onto my interfaces, and then boom, I've got connectivity. However, or I should say, correction, with PPP, it was the same thing. If I typed encap PPP on both ends of my point-to-point connection and threw some IPs on those interfaces, boom, those interfaces came up, I had connectivity, my adjacency would establish. However, with frame relay, it's a little different. Remember, frame relay is dependent upon the DLCI value, right? That DLCI value is extremely, extremely important here. And so we haven't configured that yet, and it's not, so we don't have connectivity anywhere, really. All right. So we've done router 2 and router 3. We've tested connectivity. It doesn't work. So now we're going to configure our frame relay, our static maps. And when we do the static mapping, it basically overrides the dynamic inverse ARP, right? So what are we going to be looking at here first? So it wants us to configure router 1 to use a static frame relay map. All right, so I'm on router 1. It says DELCI 102 to communicate from router 1 to 2 and 103 from router 1 to 3. So as you can see, we're actually going to hard code the entries in here to provide the connectivity across the frame relay cloud. So when I say frame relay map IP, right, I'm mapping the far end IP address, right, which is going to be 10.1.1.2 to my local DELCI value, right? So, and I'll do a question mark here because you'll see that we've got some choices that we can make. So there's the Cisco encapsulation type. You've got the IETF. We're just going to take the default. And we're going to use broadcast, right? So broadcast should be forwarded to this address. Now, this becomes very important if and when we get to take a look at what OSPF or how OSPF would behave inside of a frame relay configuration. And so we're using EIGRP, and let's go ahead and we'll put our broadcast keyword in here. And so we've got our static frame relay map for the DELC 102, and now we're going to put in 103 for router 3. So now that I have these entered in here, if I type in do show IP EIGRP neighbors, still nothing, because we haven't configured anything over on the other routers yet. But what if I were to type in do show frame relay map? All right, so let's take a look here. So we've defined the frame relay maps, right? So on serial interface 000, there's our entry. You can see we have static, right? It's a static entry because I've entered in manually. We've got the broadcast keyword on there because we put it in there. It shows the IP, the remote IP address, and my local DELC value. And it shows that the Cisco is my encap type, and then it shows me the same thing down here out this interface for the 10.1.1.3, which is router 3's IP address on the serial 000 interface. So the show frame relay map command can give you some really good information. However, when we're looking at it here, it says we're up and up, but we don't have connectivity yet. So we're going to have to continue to drive on. So it says configure R2 for static frame relay as well. So we're already under the interface, and we're simply going to say frame relay map IP. And so let's do 10.1.1.1 first. And so for DELC, from router 2 to router 1, we're going to be using DELC 201 is going to be our identifier, right? And we're going to put that broadcast keyword in there as well. And now I'm going to come back, and it's going to be DELC 203 for router 3. So if I were to say do show frame relay map, you can see that we're defined, it's active, and it shows up. But do I have connectivity across the cloud? So let's take a look now. Let's see if we get a different response now. So it's still coming back saying ping host unreachable, right? So it still hasn't sorted things out yet. And that's over on the LAN segment behind router 1. If I were to pull router 1 back up and say do show IP EIGRP neighbor, you can see that we still have no adjacency configured. So let's pull router 2 back up, and let's take a look here at the show run. Let's see what we've got on router 2. So there is the interface right now for our configuration. And what's interesting is our clock rate is shown here under the serial 000 interface, and the DCE it's showing us out here in the frame relay cloud. And I'm not sure if that was the same way on router 1 or not. Yeah, so router 1 shows the clock rate as well. So we'll take a look here back at router 2. So there's our serial interface. The encap is set to frame relay. And there are our EIGRP network statements. And so let's go ahead and wrap up the configuration on router 3, where we're simply going to say frame relay map IP 10.1.1.1, and the DELC value is going to be 301, and we'll do broadcast. And then finally we're going to do from router 3 to router 2, where we're going to say frame relay map IP 10.1.1.2, and this is going to be 302 broadcast. And what we actually, I'm sorry, we're going to have one more thing we need to do here. All right, so step 2 in part 2 is asking us to configure ANSI as the LMI type. And so LMI is the local management interface. And this kind of goes back to when Frame Relay kind of broke out sort of as its own standalone technology. And you had Cisco was involved, Stratacom, was involved, and Cisco, if I'm not mistaken, eventually purchased Stratacom. And then you had, I think it was Northern Telecom and Digital Equipment Corporation. They all kind of came together and sort of enhanced frame relay as a standalone technology, and you ended up with some different local management interface types. And basically, the analogy that I like to use is it's kind of like keep alive messages, right? And little checks that go back and forth across the frame relay cloud that allow it to check the status of the individual links that are part of the frame relay setup. So if I were to say, and we're on router 3 here, do show frame relay, and we'll do a question mark. I'm pretty sure it's LMI frame relay. Oh, we're going to have to get out of here. Let's do this. So I'll say end. So show frame relay, and there we go. So we could look at the map. We could look at the permanent virtual circuit. So we haven't looked at that yet. So there's the PVC, right? The permanent virtual circuit. It gives me the del C value. Shows that it's a frame relay, the frame relay DTE. And so then if we were to also take a look at the show frame relay LMI, which is what we're interested in, which is that local management interface, you can see that the LMI type, as you would expect, by default, it's going to be Cisco. And 9 times out of 10, if Cisco's got a proprietary technology and there's a default value, actually I'll take it even further, 99.9% of the time it's going to be the Cisco proprietary technology or the proprietary protocol that is going to be the default setting. Okay, and so as you can see right here, we basically have Cisco's our default type. It shows the frame relay that we're the DTE side here. Status messages received, inquiry sent, and timeouts. Right, so we've got some activity that's taking place. So we're going to change this now, and we're actually going to change this to the ANSI, the American National Standards Institute, version of the LMI messages. And so how do we do that? So I'm going to go ahead and go to global config mode here on router 3, go into the interface, and just simply say frame relay LMI type. And if I do a question mark, you can see we've got a couple of choices here. We could do ANSI, and again, Cisco's the default, and or Q933A. And so the differences between these guys are not substantial, but the ANSI standard is tied in with T1.617 Annex D, which is the ANSI standard, and then the 933A is just simply the ITU Q933A Annex A standard. So let's go ahead and flip this over to, it's asking for, change it to ANSI. All right, so we'll change that to ANSI. We'll go on to router 2, and we'll make the change. We'll say frame relay LMI type ANSI, and we're going to come over to router 1. Where are we at here on router 1? And we're going to say frame relay LMI type is that right? Yeah, ANSI. All right. And so keep in mind that the Cisco, by default on Cisco serial interfaces, the keep alive time is going to be 10 seconds. And we could, there we go, we've got our adjacencies up. And you could manipulate that. There's a keep alive interface command, and you can see the default is 10 seconds. So if I wanted to change that, I could, but we're not being asked to do that here, so we're going to go ahead and not touch that right now. So as you can see, my adjacencies have now come up. So if I now say do show IP EIGRP neighbors, you can see that I now have my neighbor relationships have formed. If I say do show IP route, do I now have a route over to the 192.168.30? And we do, right? And we actually picked up the gateway of last resort is 10.1.1.3. And let me go ahead and, I'm not sure, did we have a static route maybe configured here? There's the link. Aha, redistribute static. And there is our static default route. So EIGRP is propagating a static route out to us. So that's why on router 1, We've got our gateway of last resort here out to 10.113, and we have a direct route now over to the 192.168.30.10. So I'll ping from the router here. Chances are it had to ARP out, and it certainly did there, and then we've got success. And so if I can go from the router, chances are I'm going to be able to hit that from my PC, and we've got full connectivity there. And so this is a great exercise to kind of get you started here with frame relay, and there are a couple more activities that are going to take place in the PacketTracer tutorial section for frame relay. So we are done with this exercise. So we've got 100 out of 100, and again, very straightforward exercise, kind of walked you through it, gave you the commands that you need to run, and then gave you some background as well. So that concludes PacketTracer activity 4.2.1.4. Thanks for watching, and I will see you this coming Saturday.